Welcome to the Explainer. So think about this for a second. A modern connected car can pump out up to 25 gigabytes of data every single hour. That's huge. Today, we're tackling one of the biggest headaches in automotive embedded testing and development, which is just the sheer overwhelming volume of data generated by today's software architectures. And, more importantly, how we can actually manage it all without losing our minds. If you've ever felt like you're literally drowning in log files, well, you're in exactly the right place. Let's just frame the core problem we're all dealing with here. Modern cars, they're essentially data centers on wheels. When you're running tests on a vehicle, you've got a network of 100-plus electronic control units, or ECUs, managing everything from the powertrain to the infotainment system. And together, they generate an absolute deluge of data. So when something breaks, trying to find that one single software bug can seriously feel like searching for a microscopic needle in a massive digital haystack. To survive this data flood, you know we need the right tool. Enter the DLT Viewer. This is basically our essential survival lens for all this. It's a standardized utility built on the AUTOSAR 4.0 standard, specifically designed to decode, view, and store Diagnostic Log and Trace messages coming right from your device under test, your DUT. It's what actually brings order to all that ECU chaos. Here's our roadmap for the Explainer today. First up, the automotive data deluge. Second, meet the DLT viewer. Third, decoding the log levels. Fourth, configuring ECUs and contexts. And finally, filtering the noise. So, part 1, the automotive data deluge. Part 2, let's meet the DLT viewer. When you're deep in the weeds testing embedded automotive systems, you aren't just looking at one neat little stream of text. You're dealing with a massive volume of messages getting blasted out simultaneously by DLT daemons across multiple connected devices. Without a solid strategy, a tester is just staring at an unreadable stream of hexadecimal garbage pouring over a serial cable. Fun fact, this interface was originally created by Genevi just as a simple example application for receiving messages from a Linux DUT. But over time, it's really evolved into this absolutely essential utility to regain control of your data. It grabs those messages via serial or TCP/IP connections and seamlessly parses all that raw hex data into a human-readable format right on your screen. That way, you can actually understand what these target devices are trying to tell you. Moving right along to part 3, decoding the log levels. Okay, behold our triage ladder. The user manual strictly defines 6 distinct log levels used to categorize all this ECU data. And honestly, really understanding the exact difference between these 6, fatal, error, warn, info, debug, and verbose, that is the fundamental difference between an overwhelmed tester and an absolute master of automotive software debugging. Because think about it, if everything is screaming for your attention all at once, nothing is going to get fixed. We absolutely have to sort these incoming messages by severity if we're ever going to find the true signal hidden in all that noise. Let's break this down starting right at the very top of our severity ladder. First up, we have fatal versus error. Now, a fatal log level means a critical, stop absolutely everything kind of event has just occurred. Think of a critical failure in the braking control module, where the software literally cannot safely continue to operate. Now, contrast that with an error log. These are normal issues detected by the software, maybe something like a momentary sensor timeout. The software logs the fault, sure, but it has fallbacks in place, and thankfully, it doesn't prevent the module from continuing its operation. Moving one step down that ladder, let's look at warnings and info. A warn log is utilized when minor problems are detected. So maybe a powertrain temperature reading comes in slightly higher than expected, but it's not actually dangerous yet. Then we have info. This is basically your standard operating heartbeat. It's used to display routine state changes, like confirming to a tester that the windshield wipers were successfully activated. Keep in mind, if you set your default log level to info, you are going to see everything from fatal down to info, but nothing below that. Finally, let's contrast debug with verbose. And it's worth noting, both of these levels are normally turned off by default for a very good reason. Debug displays deep, granular information about the internal functionality of a software component. But verbose, oh man, verbose is the absolute hold on to your hard drive setting. It is an unmitigated fire hose of data. Seriously, you should only ever enable verbose for a highly specific, individual software component that you are actively troubleshooting right then and there. Otherwise, your entire system will just be instantly buried in an avalanche of text. All right, part 4, configuring ECUs and contexts. So how do we actually apply these log levels in the real world? Well, inside the viewer, applications and contexts are neatly organized in a hierarchy right underneath the ECU. You can think of a context as a specific, logical group of log messages within an application. When you double-click a context item in your Project Configuration tab, it pops open this configuration dialog. And this is where you really get to jump in and take control. You can change a specific context's log level, like say you want to bump it up to verbose for a module you're actively testing, and you can also toggle its trace status on or off right here. But here's the catch. Making a temporary change in the viewer just isn't enough, because if that ECU restarts, you're going to lose everything. Once you've painstakingly gone through and set your ideal default log levels for all your various contexts, you need that configuration to actually stick. So to manage these configurations long-term, you're going to right-click the ECU item directly in the project tree. The crucial point here is to follow this specific workflow. Step 1, set your desired default log level in that configuration dialog. Step 2, make absolutely sure you've checked the update data in DLT if online box, otherwise the command never actually sends to the ECU. And step 3, right-click the ECU and select Store Config. By doing this, you're persisting your settings directly into the target device itself. That means your precise, fine-tuned logging configuration remains active and ready to go even after the ECU undergoes a hard restart. Which brings us to part 5, filtering the noise. Because let's be totally honest with each other. Even with perfectly configured log levels across all your ECUs, you are still going to be dealing with thousands upon thousands of messages. Thankfully, the DLT Viewer acts as a brilliant visual triage system. Built right into the settings, you can enable these awesome visual safety nets. It's going to automatically highlight all your fatal and error messages in bold red. It acts like a beacon, instantly drawing your eye to critical failures that are probably scrolling by at light speed. And it saves you from having to manually read every single line of payload text. It'll also mark warning messages in yellow for you, and you can even set up custom marker messages that automatically highlight in green whenever you need to track specific events. But, sometimes colors just aren't enough, and you really need some advanced noise reduction. That's where the filter configuration menu comes in, allowing you to build highly complex, inclusive or exclusive filters. You can filter stuff out based on specific context IDs, application IDs, or you can even hunt down specific payload text using regular expressions. It is a total game changer if you need to isolate a very specific CAN ID or track down a variable state that's buried deep within a payload. However, you do have to be a little careful here. Keep in mind that excessive cascading filtering, especially if you're searching deep into payload text, that is definitely going to start impacting the performance of your viewer. And actually, that leads us perfectly to this really crucial warning pulled directly from the manual's limitations section. While the DLT Viewer is an incredibly powerful tool for automotive testing, it's not magic. Your own PC's hardware, so your RAM and your hard disk size, combined with the sheer volume of messages being blasted out by the target daemon, will fundamentally limit your performance. Honestly, if you ignore the triage rules we just talked about and you just turn every single context up to verbose, and then you try to run complex text filters on top of that, your PC is inevitably going to freeze up. It's a real balancing act between your hardware limits and your actual data needs. So, we're going to leave you with this final thought to chew on. Mastering DLT log levels isn't just about fixing today's software bugs. As automotive embedded systems continue to grow exponentially more complex, optimizing your data flow, knowing exactly when to use an info log versus a debug log, that's what's actually going to empower you to build the connected and autonomous vehicles of tomorrow. So get in there, filter the noise, find the signal, and take control of your data.